Okay, so if I had the square root of -9, that would give me an imaginary number because the square root of 9 is 3, but the square root of -1 is I, so that would give me 3i, which is imaginary because it has that I with it. So, whenever I have a quadratic equation equal to 0, there's something that I should go for as a gut reaction. You could complete this square. You could try factoring it, but if it doesn't factor nicely, then you're going to get some decimals and you might not be able to find your answer. If I have just an ax squared and a c term, then I can use solving by square roots. But this one I have an ax squared and a bx. So my gut instinct is to use the quadratic formula. Which is -b plus or minus the square root of b squared minus 4ac all over 2 times a. Now let's think about this before we just start solving. The only part that I need to focus on is the square root, because if I have a negative number under my square root, then that's going to give me an imaginary solution. So I am just going to take that first part, and it has a special name. It's called the discriminant, but you can just tell me b squared minus 4ac. My b value is -10. My a value is 1, because if I have x squared, it's 1x squared. And my c value is 8, so I'm going to plug all of those in. I should get -10 squared minus 4 times 1 times 8, which gives me 100 minus 32, which is the square root of 68. Now, 68 is not a perfect square, so I will get a decimal. This will be somewhere between 8 and 9 on my number line. But I can still plot it on my number line, which makes it a real number. So, I know it says circle the letter of the equation. We're not going to circle this one, even though I do have my a value circled. I'm not going to circle letter a because this is a real solution. Over here, I can also use my quadratic formula where a is equal to 1, b is equal to, well, that's hard to see. Some people would put b is equal to -36. That I know that's actually my c value because my c value does not have a variable with it. My b value, if I take a look at part A, my b value is -10 here because it was with my x term. I don't have an x term here, so my b value is equal to 0. You could use this piece of information that we called the discriminant before, or that one section of the quadratic formula that I'm just focusing on. Or you could solve by square roots. So if I add 36 to each side, I get x squared equals 36. And if I take the square root of each side, and take both the positive and negative square root, so I get x is equal to plus or minus 6. Positive 6 is a real number, negative 6 is a real number, so those are real solutions. So I'm not going to circle that one. I know I kind of went out of order, but I'm going to go down to B now. So I, again, could use the quadratic formula. A equals 3, B equals 12, and C equals -18. If I wanted to make this more simple, I could divide by the greatest common factor, but our quadratic formula tells us we can just use the numbers that we have. We don't have to change anything to make it more nice. It always works. So that would give me 12 squared minus 4 times 3 times negative 18. That's important. Negative number, and there's only one of them. This negative 4 I started with. So a negative times a negative is going to give me a positive number no matter what. So this is going to be an addition problem below. 12 squared is 144. I'm going to take 4 and multiply by 3 and by 18. I can do it all at one time. I get 216. And because I'm adding, I'm going to get a positive number no matter what. If you take a look and you get adding, you should get a positive number no matter what it is. But you should get, let's see, 360. So I can keep going and actually find the square root of 360. Or I could just say that's a positive number under my square root, so it will give me real solutions. I haven't had any imaginary solutions yet. So part E, I'm going to show you two different ways, because above I solved by square roots, which seems to take the least amount of time. If I just subtract my whatever I added originally from each side, I get x squared equals negative 4. And then I take the square root on each side, and I get x equals the square root of negative 4. If I wanted to simplify that, the negative on the inside makes me bring out an I, and the square root of 4 is 2. So my answer would be 2i. So that means I get an imaginary number. So I'm going to wait to circle this value because I'm going to make sure I get it right when I do my discriminant over here. So I get square root of b squared minus 4ac, where my b is equal to 0, my a is equal to 1, and my c is equal to 4. Remember, I don't have a middle term, so my b is equal to 0. That means I'm doing 0 squared minus 4 times 1 times 4, which is 0 minus 16, which is negative 16, which is also imaginary. Now, here I got the square root of negative 4, and here I got the square root of negative 16. Remember, when I do this b squared minus 4ac, that's only a part of my quadratic formula. It's this piece right here. I would still, if I was trying to find the zeros, I would still have to do more work to solve. And eventually I would get to 2i. But in this case, I'm just trying to figure out whether it's imaginary or not. And it is. Both ways I solved, I got an imaginary number. Oh, it's a circle, so I guess I should do a circular shape. It's not an actual circle, so you can circle part E, the letter E. Either way, if you circle the whole equation, that's fine. Alright, so for C and F, we already explained how we find each of these, so I'm just going to quickly go through the correct solutions. Make sure you have A is equal to 1, B is equal to 4, and C is equal to 21 for C. For part F, you do A is equal to 1, B is equal to negative 6, and C is equal to negative 7. And start plugging in your numbers. So 4 squared minus 4 times 1 times 21. That gives me 16 minus 84, which is negative 68. That's a negative number under my square root, which makes it imaginary. Over here, I'm doing negative 6 squared minus 4 times 1 times negative 7. That gives me 36. Negative times a negative is positive, plus 28. So that gives me square root of 64, which is 8. 8 is a real number. So my two imaginary solutions were E and C. Make sure you show all of your work for credit. 3A. What is the value of C such that x squared plus 10x plus c is a perfect square trinomial? So I'm going to draw a square. I know that a square means my base and my height are exactly the same because all four sides have to be exactly the same. If I started to factor this trinomial, I would have to put x squared there and c in the last box. Last square, sorry, because I know my base is going to end up being the same as my height. And in order to factor, I multiply the first and last one, so I should get c times x squared. And they should add to 10x. So I need numbers that can add up to 10x in order to have these two blanks. Basically, I don't know what my c value is going to be, but I do know that I want my base and my height to be exactly the same. In order for my base and my height to be exactly the same, my two numbers that I choose must be exactly the same. So my terms are 5x and 5x because that adds to 10x. That would then factor to x squared. I get x times x for my base and my height in order to get the area of x squared. X times 5 would give me 5x. X times 5 over here would give me 5x. And now I can find my c value by multiplying my base and my height that I just found. 5 times 5 would give me 25. So if I had to write it as a perfect square trinomial, I would write x squared plus 10x plus 25 for my perfect square trinomial. I'm going to do the same thing for part B. I put my x squared and my c value. And remember, I split up my middle term right down the middle so that they would be the exact same number. My middle term is negative 18. You need to be careful to see that negative out in front so that I do negative 9x and negative 9x. That means this factors to x times x, x times negative 9, x times negative 9. So negative 9 times negative 9 would be c equals 81. And if I had to write it as a trinomial, I would write x squared minus 18x plus 81 is my perfect square trinomial because it factors to x minus 9 times x minus 9. My base and my height are exactly the same. Number 4, I'm going to simplify. I have a monomial times a binomial, which means I need to distribute. 3i times 2i gives me 6i squared. 3i times negative 4 is negative 12i. And this is important right here because I know I squared is equal to a special number. So I is equal to the square root of negative 1. So if I were to square I, that means I'm squaring the square root of negative 1. If I square it with the 2 and have it already square rooted, then those two things cancel each other out. So I squared is equal to negative 1. We should know that from class. Make sure you know that tomorrow. I squared equals negative 1. So I plug in a negative 1 here. So I'm doing 6 times negative 1 minus 12i. Now I don't plug anything in for I here because I is the square root of negative 1 and I don't want to mess with the square root of negative 1 unless I can simplify it into a real number. Negative 1 is a real number because I can plot it on a number line. That gives me negative 6 minus 12i. And that is my final answer. Over here, I'm going to distribute as well. I get 5i squared plus 20i. I'm going to plug in negative 1 for I squared, which would give me negative 5 plus 20I as my final answer. Down here I have some binomials, and I know the way to multiply binomials is to use them as a base and a height. So my base is 2 minus 5i. My height is 3 minus 7i, and I can use my area model to solve. 3 times 2 is 6. 3 times negative 5i is negative 15i. 2 times negative 7i is negative 14i. And negative 5i times negative 7i. Break it up. Negative 5 times negative 7 is positive 35, and I times I is I squared. If I write all these areas next to each other, it's going to look like this. And I know that I squared is equal to negative 1. So I can rewrite these as, well, I can combine these like terms at the same time. So my 6 is going to come down. Negative 15i and negative 14i gives me negative 29i. And if I plug in a negative 1 times 35, I'm going to get a negative 35. Which is nice because it gives me 2 more like terms, 6 and negative 35. Okay, so I combine those two numbers, and I get negative 29, because negative 35 plus 6 is negative 29, or 6 minus 35 is negative 29. And then I still have my 29i from my middle term. Part E, an area model again, because I have a base of 4 plus 9i and a height of 2 minus I. 4 times 2 is 8. 2i times 2 is 18i. 4 times negative I is negative 4i. And 9i times negative I is negative 9i squared. Remember, this is going to end up giving you a real number because I squared is negative 1. Negative 1 times negative 9 is positive 9. These two diagonals are like terms. These two diagonals are like terms. Okay, so you could add those up. These two I added together to get negative 29i. These would eventually add together to get negative 29. So over here on part E, I can see I'm doing negative 9. I squared is going to be negative 1. I can add these like terms in the center. I get 14i. Negative 9 times negative 1 is positive 9. So I'm going to get 17 plus 14i. And some people may ask, why can't I add 17 and 14 together to give me 31i? Well, those aren't like terms. Just like we wouldn't add 17 plus 14x, they both have to have an I in order to be combined. Part C. What I'm going to do first is, I know that I need to write this as a complex number, just like I have on the other ones. I have a real number combined with an imaginary number. So these are all pretty much in the same form. So I want this next one to be in the same form. So what I do is try to make my denominator real. If I multiply I times I get I squared, which is negative 1, which is a real number. If I multiply the denominator by I have to multiply the numerator by I, which means I need to distribute. I get 5i minus 2i squared. And this gives me 3i squared. I squared is equal to negative 1. So I can plug in negative 1 each time I see I squared. That gives me 5i plus 2, because negative 1 times negative 2 is a positive 2. And 3 times negative 1 is negative 3. I can break this up and do 5 over negative 3 and 2 over negative 3. My I belongs with my 5/3. But if I have my denominator that's negative, I can rewrite that, because a positive divided by a negative is negative. Positive divided by a negative is negative for both of these. So I should have negative 5/3 I minus 2/3 as my answer. Okay, let's do F, because that one might have been a little bit overwhelming. But remember, I'm just going to multiply my denominator by I in order to make my denominator real, which means I multiply my numerator by I. And then I distribute. So 4I plus 3I squared all over 7I squared. I squared equals negative 1. So I'm going to do 4I minus 3 over negative 7. I can break this up, because if I'm dividing by negative 7, it means each of these terms can divide by negative 7. So I get 4I over negative 7 and negative 3 over negative 7. And negative divided by a negative is positive. Positive divided by a negative is negative. And my I still goes with that first term. Okay, number 5. Choose the numbers that solve x squared minus 4x minus 5, completing the square. You must solve by completing the square. If you want to check your answers using the quadratic formula and make sure that these C values are the same for yours, that's okay. But you must fill in the correct boxes for completing the square. So, like I did for 3A, if I look up there, I want to find the C value that makes it a perfect square trinomial. Is 5 a perfect square trinomial? Well, 5 isn't even a perfect square, and I have no A value here, so it's probably not going to be a perfect square trinomial. So, I'm just going to move it out of the way. So I add 5 to each side, and I get x squared minus 4x equals 5. Now, why do I have my equation equal to 0 when I didn't have that before? If I'm trying to solve for x, then that means my y value is equal to 0, because I'm trying to find the solutions, the zeros, to my function. So, what is that missing number? What is this C value that I'm missing? If I draw in my square of my area model, I can start filling in my values. X squared. Remember, I split that middle term up, so negative 2x and negative 2x, because negative 2 plus negative 2 is 4. And they have to be exactly the same. And then I need to find out what my C value is, but I'm not sure what it is yet, so I'm just going to make a little empty square right there, because I don't know what the area of that square is. I know that x times x equals x squared. X times negative 2 would be negative 2x. X times negative 2 would also be negative 2x. And negative 2 times negative 2 gives me that value that I'm missing, which is positive 4. So I am going to put 4 in my equation for my C value. But if I add it to the left side of my equation, I also have to add it to the right side. So what that's going to look like is I start with x squared minus 4x equals 5. I'm going to add 4 to complete my square, so I add 4 to the other side. 5 plus 4 gives me 9. Then I can factor the left-hand side. It's already done for me because I factored my area of my perfect square in order to find the c value. So it should be x minus 2 times x minus 2, but I just write that as x minus 2 squared because there are 2 of them. If it's a square, I should have something squared. Now, take a look at that. That's what our blanks are for our boxes. So I have x minus 2 equals 9. So the rectangle is 2. The oval or the ellipse or whatever that missing circular shape is 9. And then I have to solve for x. So I can take x minus 2 squared equals 9 and start solving. So I'm going to do it over here. Alright. I'm going to do it over here because I have the room there and it's also written on this side. X minus 2 squared. If I have something squared, I can take the square root on each side. I'm going to take the plus or minus square root of 9. That gives me x minus 2 is equal to plus or minus whatever the square root of 9 is. Square root of 9 is 3. Okay, now I can split this up. X minus 2 equals 3. The first part stays exactly the same because that's not where my plus or minus is. X minus 2 could also equal, or will also equal, negative 3. So what are my two values for x? Well, I add 2 to each side, and this side gives me x equals 5. I add 2 to each side. This one gives me x equals negative 1. So my values for x are 5 and negative 1. I'm going to do the same thing with number 6. X squared minus 16x. Is 17 a perfect square? No. So I'm going to move it to the other side by adding it to the other side of, well, first I need an equation equals to 0, which is this right here. And then I add it to the other side. And then I need to find out what my c value is that I'm missing. And if I'm going to put it there, I also have to put it on the other side. The way I find those numbers, that missing box there, is the same as this c value down here. So whatever number I get there. All the other ones I can fill in. X squared, I know where that goes. Negative 16x, break it in half to negative 8x and negative 8x. Then I can start factoring. This should be x times x. X times negative 8 would give me negative 8x. X times negative 8 again would give me negative 8x. Negative 8 times negative 8 is 64. So I'm going to add 64 to make my left side a perfect square trinomial. If I have to add it there, I add it here. 17 plus 64 gives me 81. My left side factors to x minus 8 times x minus 8 or x minus 8 squared. Those are my numbers that I fill in. X minus 8 equals 81. Then I take the square root of each side. And I get x minus 8 equals plus or minus the square root of 81, which is plus or minus 9. Now over here, I'm going to break those two up. X minus 8 equals 9. X minus 8 equals negative 9. Add 8 to both sides. X equals 17 and x equals negative 9 plus 8, which is negative 1. So 17 and negative 1 are my solutions. Next page. Number 7. Find the vertex of the parabola. The vertex, you should be doing x equals negative b over 2a to find your axis of symmetry. My b value is 6, so I'm doing negative 6 over 2 times a, which is 1. So x equals negative 6 over 2, which is negative 3. That's my axis of symmetry, not my final answer. My final answer is my vertex, so I can have f of x equals my equation, and I know my x equals negative 3, so my f of x when x equals negative 3 would be negative 3 squared plus 6 times negative 3 plus 11, which gives me 9 minus 18 plus 11. 9 minus 18 is negative 9. Negative 9 plus 11 is 3. So my f of x is 3 when my x is negative 3. So x comes first, then f of x, or x then y, whatever you want to call it. My vertex is negative 3, 3. And I actually know that that will be a minimum because my a value is positive, so my graph opens up. Find the vertex for the next one. Axis of symmetry. X equals negative b over 2a. So think of it this way. You use this formula when you're graphing. So if you're trying to use it at some other place, make sure you're graphing or trying to find something on a graph. If not, then you might be heading in the wrong direction. My b value is negative 2. So I'm doing a negative 2 over 2 times 1, which is positive 2 over 2. So my x equals 2 over 2, which is 1. I'm going to plug in 1 every time I see an x. So I get 1 squared minus 2 times 1 minus 5. That's 1 minus 2 minus 5. 1 minus 2 is negative 1. Negative 1 minus 5 is negative 6. So my vertex is also a minimum because my a is positive, which means my graph opens up. I have a minimum at 1, negative 6. Number 9, determine the equivalent function to f of x equals x squared minus 10x plus 1 in the form of f of x equals a times the quantity x minus h squared plus k. This I know is vertex form. So there's a couple ways I can solve this. I could use completing the square. Or I could find my vertex and plug it back into my equation, but I would have to know my a value. My a value is 1 because that's in front of x squared. And then if I find my x, my axis of symmetry would be my h value, so I could plug that in at the end. And then whatever I get for the y value of my vertex is k, and I can plug that in at the end. So either way you can do this. If I solve by completing the square, remember how I get my c value out of the way, and I have to plug in a number here that makes it a perfect square. So if I cut this in half, I get x squared, negative 5x, and negative 5x. That would be x times negative 5, x times negative 5. Negative 5 times negative 5 is positive 25. So the missing number is positive 25. I could add that to both sides. This side factors to x minus 5 squared because of my outside of my square. my base and my height. Negative 1 plus 25 is 24. Right here, I could see my potential for my value for my vertex.